Hello, I'm ETarte, math teacher. It's early February 2014, and this is the fifth in my series of videos showing part of a math tutoring session that I had just this afternoon with fifth grader Nick. At school, Nick is studying perimeters and areas of rectangles. In this session, I wanted to see if Nick could figure out the perimeter and especially the area of a rectangle whose dimensions are a whole number and a half by another whole number and a half, going somewhat beyond what he is doing in his math class at school. I'm going to draw a rectangle on this graph paper and ask you to find its perimeter and its area. I showed Nick something like this. So, can you tell me, using these little squares as a guide, how wide and how high the rectangle appears to be?
Would you say that's a half?
Yes, we'll so call that a half.
Alright.
That's what I intend.
6.5.
Okay, so write 6.5 alongside that. I don't quite like the way you've written 6.5. You need to make the 6 big. When you have a whole number fraction, the whole number should be big enough to straddle the whole fraction. That's better.
6.5.
Okay. And now its width.
And it's 10.5.
Yes. Okay. Now,
height.
pardon me?
What will we do height?
This is the height.
Alright.
What's this?
That's the height. Wait, no, that's the length.
Yes, it is.
It is.
Do you know how long this is?
Yeah, it's the same as that.
Right, same as that, 6.5. And you know how far it is across the top?
So it's 6.
Yes. And across the top?
Five and a half.
No.
Because those are all halves.
But when you're counting the length, you should not pay attention to these little rectangles. You should actually count the length same way as you count it here. 1, 2, 3, and so on.
11.
You don't have a full unit here.
Oh, 10 and a half.
Yes. Well, are you aware that if this is a rectangle, and it is a rectangle, this is going to be the same across the top as across the bottom? Okay, now, could you find the perimeter of this?
20. 34.
That's right. Write P equals 34. Okay, now comes
Area.
perhaps the most interesting part to me, and maybe to you also, the area. What must you do to the numbers to get the area?
Well, you have to multiply 10.5 times 6.5.
That's right. 10.5 times 6.5. Now, you may realize that we have had multiplication problems where there was only a single 1/2, like
now
that.
There's 2.
But now there are 2 of them. That makes it, in my opinion, more interesting than having a single 1/2.
So yeah.
But what do you think you'll do?
Well, to myself, I would honestly just make that an 11.
Well, it's not 11, it's 10.5. But tell me your idea of making it 11.
You just add this half to that to 10.5.
No, that won't work. You have to take the numbers as they are You can't move them around like
So
that.
then you would go half of 10, right?
Well, the first thing you should do is the first thing you did when there was only a single 1/2, and
You
that's just to
multiply.
multiply the whole numbers.
Yeah, so that's 60.
Right.
And you would go half of 60, right?
No, not
Right.
half of 60.
Half of 10.
Yes, and is that like this? Is that half of 10 like this, or is it half of 10 like that?
Half of 10 like this.
No, because this half is what means half of 10. It means half of the other number.
Oh, so that's 5.
Right. I want to draw a line from what here's what you've done so far. 10 times 6. Now you're going to do half of 10. So I'm drawing that line. And what is half of 10?
5.
Okay, do you know where to write the 5?
Right here.
Nope. You write it below the 0 of the 60 because soon we're going to do something with the 60 and the 5.
We're gonna add.
We're going to add them, but not yet. Well, this represents the two lines I drew. This one to represent 10 times 6, and then this slanted one to represent half of 10, which is 5, and this represents the 5 that Nick wrote underneath the 60.
Because now we have to figure out half of 6.
Yes, is that going to be this half of 6 or this half of 6?
This half.
That's right, the top half of 6. So I draw that. And what is half of 6?
3.
That's right.
And we put a 3 under here.
Yes.
And then we have no more work to do above the line. So we can 60.
68. So here's one more slanted line to represent half of 6. And this represents half of 6, which is 3. This is the 3 that Nick wrote. And then he added those and got 68. And he sees 68 as the total area. Well, this is the really interesting part, in my opinion. There is one other thing we have to do above the line. And that is, we have to take half of a half.
Well, half of a half is... Half of 2 is... Half of 2 is half.
Oh, half of 2 is 1.
Oh.
Here we have to imagine half of a half, and I have a way to help you understand this. This may be a new idea to you. This represents a candy bar. First split it in half. Okay, now...
And now you have to do it again.
Now, we'll focus on this half. This is your half because it's closest to you. Now, we have to get half of that, which means you have to cut that in half. Can you do it? That's right. And this is the final result. And what fraction of the candy bar is that?
1/4.
It is. Half of a half is a fourth. So we have to include a 1/4 here, and you can put it anywhere you want. You could make a separate line for it, but you could just put it alongside the 3. And it's the only fraction there, so you bring it down. And it becomes
68 and a 4.
Yes. So here's the candy bar split up, showing that half of a half is a fourth. And here's the 1/4 that we added, giving the correct final total area, 68 and 1/4. Now, there are a couple of ways to verify this. Do you know what verify means?
Yeah, so
What?
like check.
That's right.
Yeah.
One way is to count these squares, and I'm going to help you by doing this. I split the rectangle by this horizontal black line and this vertical black line. So you see a big rectangle, which as you see is 10 by 6, and then you have this strip across the top and this strip across the bottom, and notice the little square in the upper right hand corner. This rectangle is what by what? Whole numbers. That length by just that length
is
without going the rest of the way.
12.
Count from here to here.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes, it's 10 without the 1/2.
Mm-hmm.
Okay. And then count from here up to here, which does not include that top part.
6.
Okay. So what will you do with the 10 and the 6 to get that much of the area?
You would multiply.
Okay, and what does that give you?
60.
Okay, well that's just 60.
Mm-hmm.
Now, can you look at this part of it across the top over to here? Count how many complete square units there are.
10.
There are 10 of those, but each one of them is not.
Half.
That's right. It's 10 halves.
So it's 1, 2, 3, 4, 5.
5. Well, we got that.
That's 5, yeah.
Okay. Now count from here up to here.
7.
What is that?
Wait, these are halves.
Right.
3.
3. Well, there's the 3. Now, is there any part of the whole rectangle we haven't included yet?
The 4th.
Yes. Do you know where that is?
No.
In my picture?
Wait, he's right here.
Yes, it's this little piece right here in the corner. And it's only a fourth of a little square. See how it's a fourth of the little square? A fourth of the square unit?
Yeah.
That's the 1/4 that I told you we had to include. So everything's accounted for now, including the little 1/4 here in the corner.
Oh.
That's right, everything's included now. The 60, the 5 in this strip across the top, the 3 in this strip along the side, and this extra little 1/4 of a square in the upper right hand corner. The 60, the 5, the 3, and the 1/4.
So every attribute here relates to here.
Exactly, and that's what helps you to understand math, by seeing how the numbers relate to a picture. I believe very strongly in the idea of a mathematical picture and a mathematical exercise with numbers on the printed page, reinforcing each other, each shedding light on the other, and making the whole thing more understandable and more interesting. Do you agree with me that as we look at this video, it's just wonderful to see Nick's young mind growing? I love what I do. Thank you for watching this video.